Hello, and thank you for tuning in to Connections and Directions, our University of Michigan Civil and Environmental Engineering podcast. My name is Michelle Santillan, and I am the CEE Marketing Communications Specialist and host of this series. During our podcasts, we are featuring members of our CEE community and how their work reflects our mission of engineers in service to society. We will be highlighting our strategic directions and our commitment to diversity, equity, and inclusion. CEE's 5 strategic directions are human habitat experience, shaping resource flows, adaptation, automation, and smart infrastructure finance. Our guest for this podcast is Assistant Professor Estéfan Garcia. Professor Garcia has a bachelor's degree from UCLA and master's and PhD degrees from the University of California, Berkeley, all in civil and environmental engineering. Professor Garcia's primary research interests are in the realm of granular materials and granular systems. Granular and particulate materials represent some of the most heavily manipulated materials in our society. A fundamental understanding of their behavior at the scale of individual grains or particles has wide-ranging benefits in several fields, including civil engineering, geology, manufacturing, and planetary exploration. Professor Garcia, thank you for joining us today.
Thank you for having me.
Please share with our listeners some details about your research area and goals and how they align with CEE's strategic directions and our mission of engineers in service to society.
Sure. Well, I am a geotechnical engineer, so I study primarily soil mechanics, and my subspecialization, I guess, within this subspecialization of civil engineering is in granular soil mechanics and particulate systems. Any system that can be discretized into discrete particles that are individually a solid, but collectively have wide-ranging behaviors and sometimes even fluid-like behavior. And so I study a lot of soil, primarily because these materials are quite literally and also pun intended, but foundational to the built environment. All of our civil infrastructure, buildings, highways, everything is built upon soil. So this is why I think the strategic direction that I best fall into would be human habitat experience, because our entire habitat is situated upon these soils and just granular materials in general, primarily sands and clays and rock.
And how do you find that your area of study has specifically addressed some of the pressing issues, perhaps, that civil engineering is facing today, such as climate change and the increased amount of flooding in some cases, or soil changes that may be a result of that?
Yeah, and so it is sort of tangentially related to a lot of these areas. In the area of climate change, I don't work directly on this myself right now, but when it comes to carbon sequestration, that is also partially a soil mechanics problem. When it comes to flooding, a lot of sometimes floods, such as, for example, just up north of us with the Edenville Dam failure, that was because of a soil failure of the dam, because these dams are built out of soils. So understanding the stability of earthen materials made out of clays, made out of sands, is important for preventing or mitigating the impacts of these hazards.
And would you say that it's similar in the case of beach erosion, for example, if there's a storm and buildings then are affected as the beaches wash away? Would that be involved in what you do as well?
Oh, yeah. So basically, as much as I emphasize soil mechanics, there is no soil mechanics without water. even away from the beach. In the middle of the most inland state, water is a problem just because of poor waters, and we deal a lot with aquifers. When it comes to beaches themselves, there is a wide range of work on scour around offshore piles, um, and there is some interesting work kind of on the geologic engineering side having to do with erosion of coastal bluffs. That is obviously a wind and water erosion issue. So that's sort of how the areas of soil mechanics kind of collide with some of these offshore problems and hazards.
And how did you become interested in your area of study? Was there a course that you took or a personal experience you had that led you to pursue this area of research?
Yeah, actually, so I like geotechnical engineering because it is not the most popular area of civil engineering. I think probably most undergrads went into college wanting to study structural engineering and environmental engineering, which I love those fields as well. But also, those were the main fields that I really knew about. I did not know geotechnical engineering was really a thing until maybe late sophomore or my junior year when I took my first soil mechanics class, and I kind of became interested because I did well in the class. It just kind of came naturally to me. But actually, what I really decided to my focus on this field in graduate school because I was talking to one of my former professors and mentors when I was an undergrad, saying that I love to learn about natural hazards. I want to study how to mitigate the impacts of earthquakes, tsunamis, landslides. And I was thinking to myself as a structural engineer or just a general civil engineer, and he told me that these issues that I am interested in are actually fundamental to geotechnical engineering. Um, so I went on to take a class with him in foundation engineering. Went on to take additional courses in geotechnical engineering and geotechnical design, um, and just kind of on a whim decided to consider listing this as my major in graduate school. And then I went off to meet even more great mentors, including my advisor and other faculty, who really just kind of took me under the wing and showed and actually got me involved in natural hazard reconnaissance, specifically with the Geotechnical Extreme Events Reconnaissance Association. So it's cool. I get to work with a group of really talented scientists and engineers, and basically, whenever there's a major event that has some type of geotechnical impact, uh, this organization sends teams of people, very often locals, who go and investigate the impacts that this hazard has on geotechnical infrastructure.
So you get to have a very real presence to assist society in recovery and hopefully prevent future problems down the road, correct?
Correct. And prevention is an interesting word because we can't prevent the hazard in many cases. I mean, say for example, earthquakes. We can't control tectonics, but we can mitigate their impacts on the built environment. Um, and but then on the other hand, a lot of this stuff is preventable with a fundamental understanding of soil mechanics. I think many geotechnical engineers would agree with me that one of, if not our biggest failure in this profession was Hurricane Katrina when the levees failed. That was a geotechnical engineering failure, and that sort of thing is actually preventable. Maybe the storm itself was less preventable, but the impacts of the storm, that is what geotechnical engineering or geotechnical engineers seek to address, to reduce the impact that these hazards have on society and the people that the infrastructure protects.
So, getting to that point, how do you incorporate diversity, equity, and inclusion in your research and your courses?
And in my courses, I like to remind people that, for example, in Hurricane Katrina, unfortunately, some of the most impacted people were also the most low-income people in the area, and economics is economics, and from a political and sociological perspective, is tied to civil engineering. It is hard to take a purely technical view of our field without addressing who this field serves. We, as civil engineers, we serve people, so we need to keep the actual human beings in mind. And economics is important because with more money, you can afford better. Society can afford better protections. Lower income areas are often more exposed to hazards that we can address through civil engineering and geotechnical engineering. So I like to kind of put in these reminders into my classroom to remind students why they do what they do, not just how to do what they do, but the why. Um, as for my research group, um, kind of not necessarily from a technical perspective, but I do like to have a diverse research group. One, because the more diverse my research group is, I believe the more creative they are. Students from different backgrounds come with different perspectives, and collectively, it avoids common academic challenges such as tunnel vision or groupthink. When everyone, when sometimes students from the exact same background can look at a problem the same way and get stuck on something, and it just takes a quick alternative perspective to quickly say, hey, maybe there's a different approach, or have you thought of this? So these different students with different backgrounds definitely bring these different perspectives that really push research forward. Just because I think avoiding tunnel vision is a big is a big part of it. But also, I think it's just beneficial for students to see people in the professional workplace that with whom they can identify with. I understand that it could be rough on students when they're studying something and they're looking around from the people that are teaching them and mentoring them, but they don't see anyone with whom they personally identify with on a human level. So I think just kind of that exposure for students to see themselves in this profession, and see their neighbors and see people from their own community in these professions. I think that is very important for improving this field and just making this field more accessible to students from all backgrounds.
What classes are you teaching this semester, and do you have ideas for additional courses you would like to add to the CEE curriculum?
Sure. I'm actually teaching my first undergraduate class this coming semester, and it's kind of fitting that it is Introduction to Geotechnical Engineering. And I'm going to go over the most fundamental, or pun intended, foundational aspects of geotechnical engineering. And in the past, I've kind of taken over the courses on numerical modeling in geotechnical engineering as well as earthquake engineering. And I particularly like earthquake engineering just because I'm from California. Earthquakes are a problem. That's what inspired me to get into this field in the first place, and I like to teach about it. As for new courses, since I use a numerical tool called the discrete element method and I study particle mechanics, I want to introduce a course on granular mechanics, or maybe more broadly, particulate mechanics, to kind of study these materials that can have both solid-like and fluid-like behavior, and whose behavior is composed by solids and the void space or air in between those solids, or even the water in between those solids. And I think such a class can be generalized not just to geotechnical engineering students, but also definitely to earth and planetary science students, geology, physics majors and mechanical engineers, really any field that includes research in particulate materials.
And what is the most exciting aspect of your job, or what brings you the most joy, if you will, about your job?
I love mentoring students. That is actually, research is cool. I don't get me wrong. I love the research. I love what I study. But really, the reason I went into academia is because I also have a passion just for the student aspect of this job. So I want students to know that oftentimes my door is open. I have an open door policy just because I really appreciate it when students just stop by and want to introduce themselves. I wouldn't be here if I did not enjoy talking with the students, whether undergrads or grad students.
Is there anything else you'd like to add?
Yeah, I will emphasize the open door policy is real. So I encourage students to come on by, and then I can talk more about how I like to use the concepts in my research when it just comes to friction on on mineral surfaces and incorporate that into my leisure activities when it comes to biking and rock climbing. And so if any students want to come by and learn more, I'm happy to go on a rant about that.
How do you incorporate that leisure activity into your research?
Yeah, when I'm on the bike trails, and say I hit like a really loose sandy area, and bikers know how to get around that, but I can't help but think of the sheer strength of that material as my bike wheel goes over it. And when it comes to rock climbing, I'm kind of thinking of normal forces and the frictional strength of the material that I'm on, and how do I adjust my hand on the hold to kind of get the most frictional resistance to hold myself up. And it's probably the nerdiest way to ever look at some of these sports, but it's kind of fun for me to think about it.
Your background probably gives you an advantage over other people who don't have the technical know-how on some of these things.
In theory, but no, then there's definitely people who are just way better than me.
Thank you for listening to our podcast conversation. For more information about CEE at Michigan, please visit our website at cee.umich.edu. You can also reach our YouTube channel and Facebook, Twitter, Instagram, and LinkedIn pages from our website.